All right, so this is going to be the x of the motorist, and at some point they will equal. That's what we have to know. So what we do is we calculate
Mm-hmm.
the x of each. So for the x of the motorist, what do we know?
Do we know the initial velocity for the motorist?
Um, yeah, we do. We're talking about, when we say initial velocity, we're talking about the point where the cop sees the motorist, right? So
Mm-hmm.
this is
Okay.
our reference point right here. So from here, at this point, how fast is the car going? Well, it's going 15 meters per second, isn't it?
Mm-hmm. Yeah.
So that's why it's the velocity of the motorist initially in the x direction. The officer, police officer, we're looking for his initial velocity. Okay, what's his initial velocity?
Zero.
Zero. Good. So that'll go to zero. And the question is, what is their initial position, both of them? Well, if we just make this our reference point right here, that would be what?
Initial position.
Yeah, so we can just make it's arbitrary. I can say this is my 0 point. All right, so both of their positions are going to be initially zero because I can set this point as x equals zero. And at that point, the police officer has initial velocity in the x direction of zero, whereas the motorist is traveling at 15 meters per second. Okay, so then we look at 1/2 acceleration t squared is left for both of them. One of them has an acceleration, the other one does not. Okay, one of them is a constant acceleration. Acceleration is constant.
Velocity zero.
Okay, so the motorist traveling with constant speed. I'm sorry, that's a constant acceleration. So if you see the word constant speed, what does that mean to you? Always watch out for that. If you see that, that means that
Velocity zero.
v2 equals v1, right? So when we do v2 minus v1, not velocity will be zero, but what will be zero? Acceleration.
Oh yeah.
You see that because if these two equal each other, that top part goes to zero.
Mm-hmm.
Okay, so that means that for the motorist, I can make this whole term go to zero. You see, they're traveling at constant velocity, 15 meters per second. Are you with me? Okay, so if that's equal to zero, I know a here is 3 meters per second. What I can do now is those equal to each other. So right now I have x of the motorist is equal to the zero position. That's something I set plus the initial velocity, which is the velocity at where the cop was, right? So that's going to be 15 meters per second times t plus 1/2 acceleration, which was zero, times t squared. And this was zero because traveling at constant speed. And then x of the police officer would also have an initial starting point zero. But in this case, the police officer's velocity is initially zero. And then this is 3.0 meters per second squared. Okay? Give me a second while I text my name students. She texted me, I didn't hear it. I guess my phone is still on silent. Okay, so at this point, we know that xm will equal xp at some point when the cop catches up to him. So what you can do is you can set the 15t equal to the 1.5 t squared. You understand?
Yes.
So then at that point, it becomes a quadratic equation, subtract the 15t on both sides. And then at that point, you're going to do what?
Okay. So with the v.
Minus 15, right? You're going to take each one individually over t. So divide this by t, get that. Divide that by t, get this. Is that individually equal to zero?
So we can take 1/15.
And then that should go in there how many times? 10 times, right? So now that you know the time it takes for the cop to catch up, okay? So because you know the time, you can then plug into the individual equations and figure out the position. So how long will he travel the motors? Plug into here. 15 times that time. So he will travel 150 meters.
Mm-hmm.
The motors. Police officer will also travel that amount because the times are going to be equal, right?
Right.
So that also will equal 150. Times are equal and the distances are equal. Any questions on the problem?
No.
Okay. All right, so I have 9 o'clock students for physics too, so I'm going to have to let you go. I hope I answered some of your questions to these problems, right?
Yeah.
Okay, so what we can do is, remember you're on slide, let's see slide over. That's basically it. I hope I've clarified any doubts or questions you might have about this problem and about the concept of constant acceleration, enough for you to try some problems on your own. After all, practice, practice, practice is the key, as I keep saying. Check out the rest of the example videos. Thank you for watching, and have a nice day.